Your test review goes over sections 1.3, 1.4, 1.6, and 1.7. Your 1.3 should be relatively easy because you did quiz on that. So this is what that starts with. With the first section, you are finding the domain for each of the following functions. Just a reminder with these, if your x is in the denominator, you're going to take the expression in the denominator, set it not equal to 0. If x is underneath the square root, you're going to take the expression that's underneath the square root, set it greater than or equal to 0, and solve. And then if x is neither in the denominator nor underneath a radical like the square root, it's just going to be all real numbers. So if we look at example 1, you're given f of x is equal to -5 times the square root of 3x plus 7 minus 9. You're going to take the part underneath the radical, so that's the 3x plus 7, and you're going to set it greater than or equal to 0 and solve. For this one, we're going to subtract the 7 from each side first. So that gives you 3x is greater than or equal to -7. And then we're going to divide each side by the 3. So that's x is greater than or equal to -7/3. I do not need you to put it in interval notation or anything else like that. You can leave it just like this. For number 2, we have f of x is equal to 6x minus 4. For this one, we do not have x underneath the square root. We also do not have x in the denominator of fraction. So automatically, this one's just going to be all real numbers. And again, you don't need to give it to me in interval notation. You can just give me the all real numbers symbol. For number 3, we have f of x is equal to 3x to the 4th power minus 7x squared plus 1 all over 3x minus 12. For this one, we're going to take what's in the denominator, set it not equal to 0. So we're going to have 3x minus 12 is not equal to 0. From here, we're just going to solve for x. So we move that 12 over by adding it to both sides. That gives you 3x is not equal to 12. Then we divide each side by the 3. And we have that x is not equal to 4. For our next section, we are just evaluating each of the following. So for number 4, we have f of x is equal to 1/3 x squared plus 12x minus 5. We're finding f of -9. So that's going to give us 1/3 times -9 squared plus 12 times -9 minus 5. First thing we're going to simplify is that -9 squared, which is 81. So that's 1/3 times 81 plus 12 times -9 minus 5. Next, we will multiply. So we're going to do the 1/3 times 81. The 3 is going to turn into 1. 81 turns into 27. So 27 times 1 is just 27. Then you have the 12 times -9, which is -108, and then minus 5. I'm going to simplify the 108 minus the 5 because they are both same signs. So we're going to keep the sign, add the numbers. That gives us 27 minus 113, which simplifies to be -86. For number 5, we have f of x is equal to 3 times the square root of 2x minus 10 all over -4x squared. We're finding f of 3. So anywhere we see an x, we're just going to plug the 3 in for it. So that's going to give us 3 times the square root of 2 times 3 plus 10 all over -4 times 3 squared. I'm going to simplify the 2 times 3 underneath the radical as well as the 3 squared at the same time. So it's going to give us 3 times the square root of 6 plus 10 all over -4 times 9. The 6 plus 10 under the radical gives us the square root of 16. The -4 times 9 is -36. The square root of 16 is 4, so that's going to give you 3 times 4 over -36, which is 12 over -36. The 12 and the 36 are both divisible by 12, so the 12 becomes a 1. The -36 is -3. So that's just negative 1/3. F of x is equal to 4x squared minus 5x plus 2, finding f of x plus 2. So that's going to give us 4 times x plus 2 squared minus 5 times x plus 2 plus 2. The x plus 2 squared gives you 4 times x plus 2 times x plus 2. And we still have the minus 5 times x plus 2 plus. So from here, we're going to multiply out or FOIL the x plus 2 times x plus 2. That gives us 4 times x squared plus 4x plus 4 minus 5 times x plus 2 plus 2. From here, we're going to distribute the 4 in and the negative 5 in. So 4 times x squared is 4x squared. 4 times 4x is 16x. 4 times 4 is 16. You also are distributing the negative 5 in, so that's going to give you negative 5 times x, which is negative 5x, and negative 5 times 2, which is negative 10. And then we drop down that plus 2 after that. From here, we're just going to combine like terms. So that 4x squared is going to drop down. You have 16x minus 5x, which is 11x. And then 6 plus 2 is 8. So that's just 4x squared plus 11x plus 8. For number 7, you have f of x is equal to 18x minus 3x squared. You're finding f of 1/6. So that's going to give you 18 times 1/6 minus 3 times 1/6 squared. The 1/6 squared is what you'll do first. So you'll have 18 times 1/6 minus 3 times 1 over 36. From here, you'll multiply, so that's going to give you 18 over 6 minus 3 over 36. The 3 over 36 simplifies to be 1 over 12. I wouldn't simplify the 18 over 6 because when you do, you're multiply the 3 by 3 or 3 over 1 by something or 12 top and bottom. Instead, if you look at these two denominators, in order to make them the same denominator, it's a lot easier just to multiply the top and bottom of that first fraction by 2. By 2, as well as the 18 by 2. That gives us 36 over 12 minus 1 over 12, which is just 35 over 12. For number 3x minus 7 over 2, we're finding f of 4x minus 5. So that means that we're going to have 3 times 4x minus 5 minus 7 all over 2. So from here, we're going to distribute the 3 in. That gives us 12x minus 10 minus 7, or sorry, minus 15 minus 7, sorry, all over 2. So next, we combine like terms. So that's 12x minus 22 over 2. Your 12x and your 22 are both to give you 6x minus 11. For number 9, you have f of x is equal to 3x squared minus 6x plus 9. You're finding f of x minus 1. So that's going to give you 3 times x minus minus plus. So from here, we are going to separate the x plus 1 squared. So that's going to give us 3 times x minus 1, x minus 1, minus 1. So we're going to fill out the x minus 1s times x squared minus 2x plus 1 minus plus 9. Distribute your 3 in, distribute the negative 6 in. That gives you 3x squared minus 6x 3 minus 6 plus 9. Then from here, combine your like terms. Your 3x squared drops down. Your negative 6x minus 6x is negative 12x. Then you have 3 plus 6, which is 9, plus 9 is 18. So that's 3x squared plus 18. For our next part, we're going to be looking at piecewise functions and graphing them. The way that these are given to you is the same way that you're going to see them on your test. So I will give you the x values to plug in. I will give you the function tables. I will give you the graph and your function rule. So for this one, you have f of x is equal to x squared minus 4 if x is less than or equal to 1. And f of x is equal to 3x plus 2 if x is greater than 1. So we're going to start with the one on the left first. If you look at your inequality, it tells you what kind of circle you're going to have using that x value. So we look at x is less than or equal to 1. That one is going to give you a closed circle. The x is greater than 1 is going to give you an open circle. So if you want to write those down before you even start, you can, and it should help you when you go to graph. For, like I said, the first one, your y is equal, or your f of x is equal to x squared minus 4. We're going to plug in x values of 1, 0, negative 1, and negative 2. If we do the 1, that's going to give us 1 squared minus 4. So that's 1 minus 4, which is negative 3. Then we have 0 squared minus 4, which is negative 4. Then negative 1 squared minus 4 is 1 minus 4, which is negative 3. And negative 2 squared minus 4, which is 4 minus 4, and that's 0. So again, we said that one x value is going to have an ordered pair. That's a closed circle. So when we go to graph that one, we are going to have a closed circle on that 1, negative 3. From there, we have 0, negative 4. Then negative 1, negative 3, and negative 2, 0. So you see that there is a curve happening here with those points. So you want to make sure that you represent that curve that's happening if you have an x squared. From here, we're going to use those x values that are given to us and solve for y in f of x is equal to 3x plus 2. Where we said that the x for this one was greater than 1. So we're going to have an open circle on whatever the ordered pair is that has 1 as the x. So if we plug the 1 in, that's going to be 3 times 1 plus 2. That's 3 plus 2, which is 5. If we plug the 2 in, that's 3 times 2, which is 6, plus 2 is 8. Then 3 times 3 is 9, plus 2 is 11. And 3 times 4 is 12, plus 2 is 14. So we're going to have an open circle at 1, 5. That's going to be here. Then we have 2, 8, and 3, 11. And then 4, 14 is not. So we're just going to draw our line through, and that gives us our piecewise function. If we look at our next example, we're given f of x is equal to 1/2 x plus 4 if x is less than or equal to negative 2. As also, f of x is equal to negative x minus 3 if x is greater than negative 2. So we're going to start with the 1/2 x plus 4. Plug in negative 2, negative 4, negative 6, and negative 8. That gives you the less than or equal to, so that means that that one's going to be a closed circle for that 2, that negative 2. So that means that we're going to have 1/2 times negative 2, which is negative 1, plus 4 is 3, and that's going to be a closed circle. Then we'll have 1/2 times negative 4, which is negative 2, plus 4 is 2. Then 1/2 times negative 6 is negative 3, plus 4 is 1. Then 1/2 times negative 8, which is negative 4, plus 4. So at the negative 2, 3, we're going to have a closed circle. Then on the negative 4, 2, we'll have an ordered pair. Then negative 6, 1, and negative 8, 0. Okay, line through those points. And then we move on to the next. For the next one, we have that x is greater than negative 2. So that one means open circle. So we're going to use values of negative 2, 0, 2, and 4 in negative 2x minus 3. So if we start with the negative 2, that's negative 2 times negative 2, which is positive 4, minus 3 is 1. Then negative 2 times 0 minus 3 is negative 3. Negative 2 times 2 is 4, negative 4, minus 3 is negative 7. Then negative 2 times 4 is negative 8, minus 3 is negative 11. So at negative 2, 1, we're going to have an open circle. Then we have 0, negative 3, 2, negative 7, and 4, negative 11. So we draw the line through those. Y. And that gives us our piecewise function. For the next part in section 1.4, you are determining whether the function is odd, even, or neither. With these, you're going to plug in negative 2 and you're going to plug in positive 2. If it gives you the same number, same sign, they're even. If it gives you opposite signs but same number, they are odd. And then if it gives you two totally different numbers, it's neither. So if we look at example 12, we have f of x is equal to negative 3x minus 7. If we first find f of 2, that's going to be negative 3 times 2 minus 7. That gives us negative 6 minus 7, which means that f of 2 is negative 13. We're also going to find f of negative 2. So that's going to be negative 3 times negative 2 minus 7. That gives us 6 minus 7, which is negative 1. So f of negative 2 is negative 1. F of positive 2 is negative 13. Yes, these have the same signs, but they are totally different numbers. So this one is neither. For 13, we have f of x is equal to 7 over x. If we find f of 2, that's going to give us 7 over 2. And if we find f of negative 2, that's negative 7 over 2. These two fractions are opposites of one another, so this function is odd. For number 14, you're given f of x is equal to negative x squared plus 4. So we're first going to find f of 2. So that's going to be the opposite of 2 squared plus 4. That means that we have the opposite of 4 plus 4, which is negative 4 plus 4, which gives us f of 2 is equal. If we also find f of negative 2, that's going to be the opposite of negative plus 4. Negative 2 squared is 4, so that's going to be the opposite of 4 plus 4, which is the same thing that you had in the other one. So that's negative 4 plus 4, just 0. These two are the same number, so these two are even, or to tell you that the function is even. And for 15, we have f of x is equal to 1 over x squared plus 1. So if we find f of 2 for this, that's going to give us 1 over 2 squared plus 1. So that's 1 over 4 plus 1, which is 1 over 5. If we find f of negative 2, that's going to be 1 over negative 2 squared plus 1, which is 1 over 4 plus 1, which is also 1 over 5. Since these two are identical to one another, this is even as well. For 1.6, with these questions, it tells you that f of x is 4x minus 9, g of x is negative 2x plus 11. You're finding each of these. For 16, you're doing f plus g of x. So that means we're taking the 4x minus 9, and we're adding it with the negative 2x plus 11. Since we're adding, we can just get rid of the parentheses and combine like terms. So we're going to have 4x minus 9 minus 2x plus 11. 4x minus 2x is 2x. Negative 9 plus 11, or 11 minus 9, is 2. So that's 2x plus 2. For 17, we are doing g minus f of x. So we're taking g of x, which is negative 2x plus 11, and we're subtracting f of x from that, which is 4x minus 9. So if you see here, the order in which you place your expressions matters. It depends on what's in the parentheses and where it's in there. So with this one, we're going to distribute the negative to the second set of parentheses. I don't know why this isn't. There we go. So this is going to give us negative 2x plus 11 minus 4x plus 9. Combine your like terms. The negative 2x minus 4x is negative 6x. The 11 plus 9 gives us 18. So that's negative 6x plus 18. Still using that f of x and that g of x. For 18, we're finding f times g of x. So this means we're going to take f of x, which we said is the 4x minus 9, and multiply it by g of x, which is negative 2x plus 11. Foil this out. The 4x times negative 2x is negative 8x squared. 4x times 11 is 44x. The negative 9 times negative 2x is positive 18x. Negative 9 times 11 is negative 99. So with this, you're just going to combine like terms, which is the 44x and the 18x. So that negative 8x squared drops down. The 4 plus 8 is 12. You carry the 1. 2 plus 4 is 6, so that's 62x minus 99. For number 19, you have f plus g of negative 3. For this one, we're going to take f of x, add it to g of x, but plug in the negative 3 in for x in both of them. So to first, we're going to find f of negative 3, which is going to be 4 times negative 3 minus 9. So that gives us negative 12 minus 9, which is negative 21. We're also going to find g of negative 3. So that means that it's going to be negative 2 times negative 3 plus 11. So that's 6 plus 11, which is 17. From here, we're adding these. So we're going to take negative 21 plus 17 and just add them. So the 1's going to turn into 11. The 2 turns into a 1. 11 minus 7 gives us 4. 1 minus 1 is 1. We keep it negative since our bigger number was negative. That's negative 4. For number 20, we're finding f times g of 3x squared. So anywhere we see an x, we are going to plug in the 3x squared for it. So that means we are going to have f of 3x squared times g of 3x squared. So we said that f of x is the 4x minus 9. That means it's going to be 4 times 3x squared minus 9. The g of x is negative 2x plus 11. So that's going to be negative 2 times 3x squared plus 11. If we look at the first set of parentheses, the 4 times 3x squared is 12x squared minus 9. The second set of parentheses, the negative 2 times 3x squared, is going to give us negative 6x squared plus 11. So from here, we're going to FOIL this out. So 12x squared times negative 6x squared is going to give you a negative 72x to the 4th power. Then you have 12x squared times 11. Your 12 times 11. 1 times 2 is 2. 1 times 1 is 1. 0 goes down. That's 2 and 1. We add, so that's 132. So we said that's going to be positive 132x squared. Then we have negative 9 times negative 6x squared, which is positive 54x squared. And negative 9 times 11, which is negative 99. From here, combine like terms. Your like terms are the 132x squared and the 54x squared, which gives you negative 72x to the 4th power plus 186x squared minus 99. For 21, you have f minus g of negative 7. So you're going to do f of negative 7 minus g of negative 7. So that means that you're just going to have f of x, which we said is the 4x minus 9. So that's going to give us 4 times negative 7 minus 9 minus g of x, which we said is negative 2x plus 11. So that's going to turn into negative 2 times negative 7 plus 11. The negative 4 times negative 7 is negative 28. The negative 2 times negative 7 is 14. So your negative 28 minus 9 is negative 37. Minus 14 plus 11 gives us 25. These are the same thing as saying add the 2, keep the sign since they're the same, and add your numbers. So it's going to stay negative. 5 plus 7 is 12. We carry the 1. 2 plus 1 is 3, plus 3 is 6, so that's negative 62. For 22, you're going to use f of x is equal to 3x squared minus 9x, and g of x is equal to 5x minus 3. You're finding the following. For 22, you're finding f of g of x. So you're going to take g of x, plug it in for f of x. So that's going to give us 3 times x squared, which is going to be 5x minus 3 squared minus 9 times x, which is 5x minus 3. You need to separate the 5x minus 3 squared and FOIL it out. So you're going to have 3 times 5x minus 3 times 5x minus 3 minus 9 times 5x minus 3. If we FOIL this, you're going to have 3 times 25x squared minus 15x minus 15x plus 9 minus 9 times 5x minus 3. If you combine like terms within your first set of parentheses, you're going to have 3 times 25x squared minus 30x plus 9 minus 9 times 5x minus 3. From here, you're distributing. So 3 times 25x squared is 75x squared. 3 times negative 30x is negative 90x. 3 times 9 is 27. The negative 9 gets distributed as well. That's going to give you negative 45x plus 27. From here, you're combining like terms. The 75x squared drops down. You have negative 90x minus 45x. They're the same sign, so keep the sign, add the numbers. That's negative 135x. Then you have 27 plus 27, which is 54. So you have 75x squared minus 135x plus 54. The next one that you're going to look at for 23, you have g of f of x. So you're going to take the 3x squared minus 9x, plug it in for x in g of x. So that means you're going to have 5 times whatever f of x is, which is 3x squared minus 9x minus 3. From here, simplify. 5 times 3x squared is 15x squared. 5 times negative 9x is negative 45x. Then that minus 3 drops down. You do not have any like terms, so that is your answer. For 24, you have f of g of negative 1/5. For this one, you're going to plug in the negative 1/5 first for x in g of x and simplify that. Whatever that is, then you're going to plug that into f of x and simplify. So first find g of negative 1/5. That's going to give you 5 times negative 1/5 minus 3, which is negative 1 minus 3, and that's negative 4. So technically, you're really finding f of negative 4. We said that f was the 3x squared minus 9x. Yep. Yeah, so you're working inside out with these. So that's why we worked with the g of 1/5 or the negative 1/5 first. So we found whatever that was equal to. Now that you're going to plug in for x in f of x. So that's going to give you the 3 times negative 4 squared minus 9 times negative 4. So the negative 4 squared is 16. That turns into 3 times 16 minus 9 times negative 4. Your 3 times 16, 3 times 6 is 18, carry the 1. 3 times 1 plus 1 is 4, so that's 48. Then you have negative 9 times negative 4 is a positive 36. You're going to add these. The 6 and 8 is 14, carry the 1. Your 4, 1, and 3 gives you 8, so that's positive 84. For 25, you're finding g of f of negative 2. So we're going to find f of negative 2 first. So if we work with the f of negative 2, we're going to have 3 times negative 2 squared minus 9 times negative 2. The negative 2 squared is 4, so that's 3 times 4 minus 9 times negative 2. 3 times 4 is 12. The negative 9 times negative 2 is positive 18. So that gives you 30. So really, you're finding g of 30. We said g of x is 5x minus 3, so that's going to be 5 times 30 minus 3. The 5 times 30 is 150. Minus 3 gives you 147. For your next section, you're working on 1.7. So the first part of this that we're going to do is find the inverse of each of these. Remember, when you're finding the inverse, you're changing f of x, g of x, h of x, anything of x into y. Then you are going to switch your x and the y and resolve the equation for y. When you give your answer, it's going to be f to the negative 1 of x, g to the negative 1 of x, h to the negative 1 of x. One of those. Okay? So for number 26, you're given f of x is equal to 1/3 x minus 2. This f of x is equal to y. So y is equal to 1/3 x minus 2. From here, you're going to switch x and y. So that's going to turn into x is equal to 1/3 times y minus 2. Move your 2 over, add it to both sides. That gives you 1/3 y is equal to x plus 2. From here, you're going to divide each side by the 1/3, which means multiply by the reciprocal. So if you multiply each side by 3, you're going to distribute it on the right side. On the left side, it cancels out the 1/3 to where you just have y is equal to the 3 gets distributed in. That's 3x plus 6. So from here, the only thing that you need to do is change out that y to be f to the negative 1 of x is equal to 3x plus 6. for 27, you're given g of x is equal to 3x minus 1 all over 2. This is the same thing as saying y is equal to 3x minus 1 all over 2. So if we switch our x and our y, that's going to give us x is equal to 3y minus 1 all over 2. We start this one by multiplying each side by 2. That cancels out on the right side and gives you 2x is equal to 3y minus 1. Subtract your 1 over to get y by itself. That's 3y is equal to 2x minus 1. Then divide each part by the 3. And that gives you y is equal to 2/3 x minus 1/3. That's not your answer. Your answer has to include the g. So, oh, I did. So this should be plus 1, this should be plus 1, this should be plus 1, and this should be plus 1/3. Thank you. So instead of you giving it to me as y is equal to, rewrite it as g to the negative 1 of x is equal to 2/3 x plus 1/3. For number 28, you have h of x is equal to 4/9 x plus 2/3. Change the h of x to be y. Then switch your x and your y. So x is equal to 4/9 y plus 2/3. Now, I don't want to work with fractions with these, so I'm going to multiply everything by my least common denominator, which would be 9. So if I multiply everything by 9, it's going to give me 9x is equal to 4y plus the 3 turns into 1, 9 turns into 2, 9 turns into 3. Multiply that by 2, that's 6. So now I'm not working with any fractions. I'm going to move my 6 over, subtracting it from both sides. That gives us 4y is equal to 9x minus 6. And then I'm just going to divide each side by the 4 to give us y is equal to 9/4 x minus 3 over 2. Your numbers have to be simplified. This is not your answer, though. You started with h of x. You found the inverse, so you need to label this as h to the negative 1 of x is equal to 9/4 x minus 3/2. For 29, you have f of x is equal to 7x minus 12. So again, we're going to change the f of x to be y is equal. Then we're going to switch x and y to where this is x is equal to 7y minus 12. And we're going to solve for y. So we're going to add 12 over. That gives us 7y is equal to x plus 12. Then we're dividing each side by the 7. So every term gets divided by 7. And that's y is equal to 1/7 x plus 12 over 7. Again, you started with f of x. So this is going to be f to the negative 1 of x is equal to 1/7 x plus 12 over 7. The next part asks you to determine if the given functions are inverses. Remember, we said that if you wanted to do these like the textbook goes over, you can do f of g of x. Then you can do g of f of x, and then see if the two are equal to one another. You should be left with x if that's the case. If you don't want to use that method, you can do something like f of 2. Whatever you get from that, plug it in for g of x and see if you get 2. If that's the case, then they're inverses. I'm going to choose to do it the last way that I just said. So the first one that we have, we're given f of x is equal to 9x plus 2. G of x is equal to 2/9 x minus 9. So if I'm going to find f of 2 first, that's going to give me 9 times 2 plus 2, which is 18 plus 2, which is 20. From there, I'm going to find g of 20. So that's going to be 2 over 9 times 20 minus 9. The 2 over 9 times 20 is 40 over 9 minus 9 is 81 over 9. So that gives us negative 41 over 9. That is not equal to that. Sorry, not equal to the number that you plugged in. So since that negative 41 over 9 is not equal to the 2 that you plugged in for f of x, these two are not inverses. Tomorrow you can just give me a yes or no. I don't need you to write it out. Like I said, you can give me a yes or no. 431, you have f of x is equal to 1/2 x plus 4. G of x is equal to 2x minus 8. We're going to find f of 2 first. So that's 1/2 times 2 plus 4. That gives us 1 plus 4, which is 5. So now we're going to find g of 5. G of 5 is going to give us 2 times 5 minus 8. 2 times 5 is 10. Minus 8 is 2. Your 2 that you got here is the same number that you plugged into f of x. So these two are inverses. $32. So for 32, you have f of x is equal to 4x minus 2/3. G of x is equal to negative 1/4 x minus 1/6. So again, I'm going to do this the f of g of x and the g of f of x way. So if we do f of g of x, that's going to be 4 times negative 1/4 x minus 1/6 minus 2/3. So if I distribute that 4 in, that's going to give me negative 4 over 4, which is just negative x, minus 4 over 6, minus 2/3. That then gives me negative x minus 2/3 minus 2/3, which is negative x minus 4/3. If I then find g of f of x, I'm going to take g of x, plug it in for x in f of x. Or sorry, f of x, plug it in for x in g of x. So it's going to give me negative 1/4 times 4x minus 2/3 minus 1/6. So this is going to get distributed in. The negative 1/4 times 4x is just negative x. Negative times a negative is a positive 2 over 12 minus 1 over 6. So then this simplifies to give me negative x plus 1/6 minus 1/6, which cancels those out, and I'm left with just negative x. These two are not equal to one another. So because they're both not x, these two are not inverses. For 33, we have f of x is equal to negative 5x plus 11. G of x is equal to 8x minus 5. So if I start with doing f of g of x, this is going to give me negative 5 times 8x minus 5 plus 11. So I distribute in, that's negative 40x plus 25 plus 11, which is negative 40x plus 36. Next, if I find g of f of x, we're going to take the 8x minus 5, plug in the negative 5x plus 11 for that x. So it's 8 times negative 5x plus 11 minus 5. 8 distributes in. That gives us negative 40x plus 88 minus 5, which simplifies to be negative 40x plus 83. Again, these two are not equal to one another, so they are not inverses. So once again, it's totally up to you which way you decide to use the inverses, not inverses ones. So either do what we just did here with, you do the f of g of x, g of f of x. You should both get x if they're inverses. If you don't want to use it this way, you don't have to. You can plug in a number for f of x, simplify that, whatever you get from that, plug it in for g of x, you should get the same number you plugged in for f of x.